Good Thursday to you, everybody. Income 651. Welcome to week boom 5. Let's move this up just a little bit so I can see what I see. There we go. That's better. How is everybody doing? Week 5. We're not quite at the halfway point in the semester. There's 16 weeks, but in terms of the work that we actually do, well, I guess finals is work, but it's about 15, so somewhere around 7.5. So we're getting there. We're getting there. And speaking of getting there, let's get a little more coffee with a little cocoa. I mean cacao. Sorry, I should say. Um, Very good as an anti-inflammatory, which for those of us that have inflammatory conditions such as bronchial asthma, which I have, tremendous help. So if you have issues with inflammation, and that could be, autoimmune disease, skin, bowel problems, most of these are related to inflammation, try a large tablespoon of 100% raw cacao. Okay, you can buy it off Amazon. You can get organic. You just go to the store and get Hershey's baking cocoa. Now, I'll warn you that since it's unsweetened, you may need to put a little sweetener in there. I stay away from processed sugar. I use a sweetener substitute. I happen to like xylitol made from birch bark. I don't like things like stevia and monk fruit. That's too sweet for me. But it doesn't have any sweetness in it as chocolate, so it might be sort of All right, but enough about me and my peculiar health habits. Let's get to you. Okay, so for this week, week 5, we're going to continue our investigation about data. It's gathering, it's measuring, and some of the things that go right with it, and some of the things that can go wrong with it. And then, in addition to that, excuse me, I'm gonna have you at least become familiar with something that's called a SWOT analysis, SWOT. Okay, this is something that's extremely common in business, in communication, and really in any situation in which you need to make an analysis of the pros and cons of an organization, of a project, an undertaking. And just as a spoiler alert, SWOT stands for strengths, weaknesses, opportunities, and threats. So you evaluate whether it's, say, your PR plan that you're putting together for an organization that you'd be pitching. Wink. You say, okay, what are the strengths of this plan? What are the weaknesses of this plan? What are some of the opportunities that it affords by way of application, and what are some of the threats to it? What are some of the things that can go wrong? All right. In courses past, I've had people do a full on SWOT analysis and given them case studies. I'm not doing that this time, at least at this stage. You will have that opportunity in further stages for your PR plan. So at this point, just make sure that you're familiar with it. Okay. Also, I've added some material of my own making. Now, I want to tell you, I always with serious consideration, think hard before I put in anything that I have written into a class that I'm teaching. It's not because I believe that I don't produce material worthy of class and examination. That's not it at all. I stand very much behind the work that I produce. But it's rather, I don't want you to feel like because I'm the author, I don't want you to feel that you should somehow treat the material any differently. So for those of you who've had me in classes before, you should know this. And those of you, if this is your first time, I will tell this to you so that you know. You can agree or disagree with me. That makes absolutely no difference. in how I evaluate your work. You can see things from my particular perspective, and we all have biases that we come to, a process with. Now, the best thing when you're working as a researcher is to, first of all, acknowledge the bias within yourself. If there's a chance that the bias might influence your work, acknowledge that in your work and be an investigator, not an advocator. I'll get back to me in a second, but the reason for this is, look, if what you want, and this is what you should want as a researcher, is to come up with answers to important questions, excuse me, the most beneficial thing you can do is propose answers or even ask questions about the questions and then test them. And if the answer is yes, the answer is yes. If the answer is no, the answer is no. But the main thing that you're after is, what is it that's driving this phenomenon? I see a phenomenon in society because, we as communicators are social scientists. This is a critical issue. Why is it that housing prices are up? Why is it that men and women are waiting longer and longer to get married and have children? Is this a good thing for the future? Is it a bad thing? Is it a non-factor? Whatever the question might be. Okay, whatever your vocation is, whatever issue you're drawn to. Number one, figure out what the important questions are. Number two, figure out ways to test possible answers. And then number three, just test them. Because if the answer is no, good. Often coming up with the right answer for the important question is a process of elimination as to what doesn't work, as to what isn't the answer. And if you're not an investigator, if you're an advocator, if you want to have something confirmed or disproven when you do work, the odds of you missing the actual cause of what's going on, they go way up. And the odds of you figuring out what the right answer, and then, because we're action-oriented beings, and as a consequence, the right action happens to be, those go way down. All right. So when I give you, I always think long and hard before giving you anything that I've written. Right. If you disagree with me, because there'll be things in this piece. I've given you a piece this week to look at called "How Not to Get Fooled by the Numbers." I probably, to make the pun effective that I was going for, I probably should have put a semicolon or a hyphen or at least a comma in there. How not to get fooled by the numbers, meaning systematically, this is how you don't get fooled, but because numbers can fool us, so it didn't work. It's sort of like, it's time to eat, grandma. It's time to eat, grandma. Commas can make all the difference. But anyway, in this piece that I've given you, I look at how statistics, number one, tend to affect people. Okay, people place different depths of validity in the outcome expressed numerically as opposed to linguistically, which is, someone that's interested in semiotics, more than interested, I'd say I'm obsessed. That's the study of signs and how they affect us. To me, that's really weird. That's really weird that we do that, but that's just how the brain works. Because when you look at it, that I think did I use this before? I'll use it again. These are both abstractions, A and this representation for the number 2. There's nothing in this shape abstraction that says there's that is an ascribed, enculturated, learned association. Likewise, now in its original form, in the Arabic form, there were 2 angles, so this represented 2 items, but that's long gone. Okay, I mean, take the number 9, its present form. There's nothing in that number that's representative of 9 items. It's a symbolic, enculturated, a learned association. So in both instances, letters and numbers, they are learned associations. But somehow, the mind ascribes greater validity to numbers. You need to know this. Okay, why do you need to know this? Because you need to, first of all, I mean, this could be helpful in your own life, for you to understand this. But then, secondly, when you get out into your communication careers, use your awareness of this phenomenon responsibly. If you're going to express something numerically by way of communication, make sure that it's valid. That is, that the numbers are actually backed by the demonstration of the phenomenon, not that the numbers are used in a way that, as a symbol, carry the meaning that you want, and because that's how they're most frequently used, or I should say misused. So that's the point of the article that I've given you. Spoiler alert. But there are going to be things in there that I touch on that you may go, wait a second. I start the piece by talking about, it was something I wrote for a magazine in 2024, by talking about what happened to the Democratic candidate for the presidency, Vice President Kamala Harris, and her loss. The point is not to crack, Kamala Harris or the Democrats over the head. That's not the point. The point is to say how we as the public can be fooled by numbers, and even how those that produce numbers can be fooled by numbers. Be careful of this as a communication professional. And then I go on to other things to make this point. I talk about the replication crisis. You need to know this in the social sciences, that this is a problem within our field. All right. And by the way, out in the wider world, there are others who are aware of this as well. And this poses a certain challenge to the strength and staying power of social science research. I mean, it just gets dismissed. Like, you guys are just making this up. This never could be replicated. Okay, well, we got to be doing something about that. We have to either have better methodology on the front end. Why is it that we're getting results that can't be repeated? All right. Or more honest representation of the outcome on the back end. Something's not squaring. Okay. So I talk about the replication crisis. And then I look at 3 scenarios in which, we have to ask the question, was this data presented in such a way that could never be replicated? Was it accidental or was it on purpose? And I touch on areas that the reason I touch on them, it's not to inflame political orientation. Rather, it's to make the point that when we have numbers from studies, from analyses, and you don't necessarily study, you take a survey and you blah, 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 okay, that can't be repeated. Okay, they're non, because I mean, can't be repeated in the sense that if you replicate them, you get something completely different. Okay, this often has serious socioeconomic consequences. I mean, there are instances in which it has socioeconomic consequences when we get it right. But I give you 3 instances in which I'm asking you, to take a look at the numbers. Now, I give you some behind the scenes. In one of them, I talk about the legalization of abortion. And one of the key individuals, one of the first 4 founding members of the organization that was pivotal in the legalization of abortion, Dr. Bernard Nathanson, admits that they lied about the data. Okay? But interestingly, back to the point that I wanted to make originally, is that it being a number, people just didn't seem to be interested. That, it's like, hey, we fudged this. And they're like, yeah, we sort of already made our mind up. All right. I'm doing that not to push people's buttons about where you might be at on abortion. I'm doing that to demonstrate. And I put links in this. You reading this and answering the discussion questions doesn't require you to chase down these links. But again, as a researcher, I'm putting in the data that supports the analysis. All right. And so the legalization of abortion had serious socioeconomic consequences for this country. I mean, there's no question about that. Another organization that I put under the microscope by way of how data is used is Black Lives Matter. Now, I have my own opinions about the organization, but my opinions about the organization is not the point of having the organization in there. It is rather to look at the data, look at the numbers, and see what the numbers say, and then look to see what the organization says. And this is what we should always be doing. Well, I don't care where you are on the political spectrum, and this is back to our bias. Okay, when somebody starts throwing a number around, whether it confirms your bias or it pushes up against a position that you have, go look behind the number. And if the organization or the individual can't give you the specifics or won't, man, that is a red flag. If they will not give, fully divulge the data, the raw data, that's almost a dead giveaway. I'm not talking about Black Lives Matter. I'm talking about any organization. That is almost an instantaneous dead giveaway. All right, they have either not done the research themselves, or they have, and they're fudging the numbers. Right. And then finally, the third example that I touch on is the claims of COVID-19 vaccine efficacy by the companies that manufactured the vaccine. And again, I have my own opinions about that, but that's not the point of putting it in there. Okay, so what's the point of all of this? Sorry, you've taken up 15 minutes of your time. The point is, I'm not requiring that you agree with me or disagree with me. And if you disagree with me and you say so in your discussions, okay, so long as you're referencing the numbers. Okay, because what we're about here is the research and the data process that goes into public relations. And it is our job to get it right. First and foremost, as observers, professionals, then citizens, or maybe citizens, professionals, however, going from one identity to another, okay, as observers, and then as practitioners. It's our job to get it right. And as part of that, we should be asking questions whenever data is thrown out to support positions. I want you to be suspicious. Two reasons. I want you to be suspicious when numbers are used to try to drive home, especially in politics or social change, some points. Number one, okay, the first reason I want you to be suspicious, because doing good data analysis is hard. It can be complicated as a practice, as a science. And many people make mistakes. They get it wrong. And number two, whether they do it intentionally or not, that sort of goes down a different rabbit hole. People lie, and they lie with numbers, which brings me full circle back to the reason that I'm giving you this piece. They lie with numbers, knowing full well that people vest greater validity in numbers as opposed to letters and words. Okay. It's incumbent upon us as communication professionals to be aware of that. All right. So that's the point of the piece. It's not to make you agree with me. It's not to make you read my stuff. There's no indoctrination going on. If in your discussion section, hey, I disagree with what you're up to here. I don't think this is a valid point. Hey, that's cool. Okay. But again, make sure that you're looking at the numbers. Okay. All right. So, and by the way, I realize you're a captive audience. I take that very seriously. So I don't just, it's the exception rather than the rule that I put any of my own stuff into the curriculum for the course that we have. You know, and I respect the fact that you know, that there's this, I'm the instructor and you're the learner, and so, you know, here, read this or else. Um, okay, so again, there's no requirement. You know, usually I make these things extra credit. Maybe I should have done that in this instance, so you can say, yeah, I ain't interested in what this guy has to write. You know, all right. So maybe you know, I don't know. I'll just leave it as it is. But again, you're under no obligation to agree with what I'm up to. All right. So that's what we're going to be doing this week. Okay. Take a look at it. Now, the other thing, of course, the big ticket item for this week is the completion and turning in of your phase 1 for the campaign. All right. And that's due the 13th. And when is that Friday? Yeah, that's a Friday. Yeah, we're a little out of sync. Okay, so again, now take note that the discussion questions are not due until Tuesday at 11:59 next week, because you know we got pushed a little bit out, and I think I'll maintain that schedule at least until we get to spring break, and then we'll ratchet it back to the Monday night. Okay, and in this instance, especially that you might be pushing and hurrying to finish your phase 1. Okay. Um, and you know, there's the upload link in the assignment sheet. Excuse me, in the assignment folder. So much to keep track of. And Canvas. All right, that is due tomorrow. Okay. Okay, everybody. Let's take a look at what you did last week. The questions. Some types of data that you just, you know, it's you know, types of data is be just like, you know, I don't know what, something that's of tremendous interest and importance to you. Maybe fruits, foods, I don't know. You know, I do a lot of shopping. You just need to know this. Okay, whether you go on to be a researcher or not, you need to go bang, bang, bang. Okay, question number 1 from last week. As discussed in stacks, please list and briefly explain the 4 types of observational data. Choose 2 of the 4 types to provide an example of these. Okay, so again, for a test purpose, I might say, you know, what are these, you know, what are the 4 types of data, and you list them, or I say, you know, of the data types of data here listed, which are the 4 types, something like that. Okay, Carolyn, you went last. Let's take you first. The 4 types of observational data are nominal, ordinal, interval, and ratio. Okay, they can be summarized in 2 distinct classes: categorical or continuous. Okay, that's exactly right. And I'm going to go back to you here, Carolyn, in just a second. But here's something that I want to make sure that everybody understands, and you understand this intuitively. All right. When we talk about types of data, we are not talking about distinct things. Okay, let me illustrate what I mean. When we talk about different kinds of writing instruments, all right, okay, we'll use 3. If I had 4, I'd give you 4, but I don't. Oh, yes, I do. All right. If I said, here are 4 writing instruments: a pencil, a very cool fountain pen from the house of Sigmund Freud. Yeah, I may have a problem. A Sharpie marker and a highlight marker. These are distinct things, okay? Because a pencil is wood with a graphite core and a little, you know, I don't know if it's actually rubber, as in from a rubber tree anymore or not. Okay, and then a metal casing. That is distinct in its form and function from this, which is just a hollow plastic tube with a fibrous core that's been soaked in a dye. All right. If I drop this in water, nothing's really going to happen. If I drop this in water, all the dye is going to leak out. They are separate things, physically different. The types of data, these are not separate things. These are separate ways to describe the same thing. Excuse me, pardon me. Do you understand? And you know, this might be on the test. All right. They are separate ways, different ways to describe the same thing. Pencil, for example. Let's go to the two categories of data, categorical and continuous. Categorical is just what it says it is. I'll go back to you in just a second, Carolyn. That is, we're breaking things down, and we're putting limits on what those things are and putting them into distinct numerical categories. Continuous data is, well, we're describing a transition from one thing to another, something that it has, the name implies, is on a continuous state. We could describe this pencil with categorical data or with continuous data. We could say, say of these different writing implements, we could put them on a scale, and we could create categories of 1 ounce to 3 ounces, 3 ounces to 5, 5 ounces to 7, 7 to 9, 9 to 11, and weigh them and say which of these items falls into that distinct category. Now, this might be, what's this thing weigh? Ounces something. This might be 1 point something ounces, but nope, it goes right into that first category. Now, this is metal. It's actually heavier than, you might imagine looking at it on the screen. This might land in the 7-ounce category, right? It's simply a way of describing the thing. Or we could just describe this continuously. We could ask people, we could give them these different implements. Let's just take 2. I say, would you hold this in your hand, please? All right. Describe the feeling of this writing implement as opposed to this one. Now, this is metal. It's cool. Feels heavy. Okay, the front end is heavier than the back. I mean, if I try to balance it, it's going to fall because it's so heavy on the front end. The balance point is about right there. See how much of this side sticks out? Okay. Still data, still something about these things. It's just a different way of describing a phenomenon. Now, why choose one as opposed to the other? And that's one of the questions we're going to get at. All right. Let's put a little pin in that. Go back to Carolyn. Categorically speaking, nominal measurements observations include sex, race. Ordinal measurements include places those observations in some type of order. Continuously speaking, interval measurements assume that the distance between observables are equal along the continuum. All right. While ratio measurements aid the requirement of absolute 0 point to continuum. Okay. An example of nominal measurements would be the demographic survey, which almost always required prior to things like scholarship applications. I just finished applying for the Fulds Honor Scholarship. A little flex there, Carolyn. I'm kidding. For my son. Oh, it's for your son. Okay. Which asks about sex and race. Here's a sample. In the PR realm, some companies measure engagement using DAU, MAU ratio, and this is from Westerland, to evaluate percentage of monthly users who engage on any given day, also known as stickiness. How stickiness indicates product market fit and predicts retention. High stickiness. Low stickiness suggests users do not need the product frequently enough to form habits. Okay. Excellent, excellent, excellent. Okay. So remember, the takeaway from this question is, number 1, know what these categories are. So there are 4 that are grouped into 2. And then number 2, understand that when we're talking about this, we're talking about ways to describe a thing. Okay, just or different ways to describe a thing. Now it's not just like, oh, hey, whatever we want. There are reasons that we would use categorical as opposed to continuous. We'll get to that in just a second. Question number 2. What are some of the advantages and disadvantages of categorical continuous data? Find a real world example of this. I mean, you go out and say, okay, well, let me tell you, Catherine, let's take you, or Cinda. Sorry. Stacks notes that an advantage of categorical data is that they're simple to observe, but can be difficult to explain. This is because classifying general data using terms such as large or small, for example, can be subjective in that in that quantifying what is interpreted as large or small is not fixed by universal definitions. Okay. Now remember, I'm going to ask you, come exam time, to put whatever answer is into plain, simple English. If you understand that, if everybody understands that, we're on point. Okay. Two advantages of continuous measurements are that the observations can be clearly interpreted and they can be discussed in categorical terms ranging from ratio to interval to further down from ordinal to nominal. Okay. Let me see what you say next. Disadvantage of categorical measurements were reported by DeLong and Fernbach. Don't know if that's how they pronounce the name, but I like the French and the German, who couched this data from the perspective of how humans think. The authors noted that categorical measurements can result in assumptions that data are more alike than they really are, that difference in data can be magnified, the bias can easily filter into one's measuring, and that categorical data can be treated as if they are fixed. Okay, excellent. This is an extremely important point that Cinda is on here. When you put things into set categories, you may be putting artificial barriers between how it is that people think about the phenomenon or the object or the website or whatever it is you're doing. Okay, and that can skew, that can give you a false picture as to what's going on. Be careful of that. All right, question number 3. Good answer, Cindy, by the way. Question number 3. Why are Likert scale type statements often mismeasured when used to measure interval variables? Now we're getting into the granular stuff, and I love it. Okay, I love it. Ashley, Likert type scales can be an effective measurement tool for researchers in many instances, such as in polls and surveys. It's relatively easy to develop results, and the results are considered reliable when utilized effectively. However, Likert type statements can also be mismeasured. And so from this, there's a couple things built into this that you should know. All right. That is, if you're going to be asked about this. First of all, what's a Likert scale? Okay, you just got to know that. What's an example of a Likert scale? All right. How might it help a researcher express a phenomenon, and how might it be problematic in expressing the phenomenon? You should know things like that. All right, but back to you, Ashley. According to Stacks, the basic assumption of the Likert scales are that 1, the scale responses are interval in nature. 2, the ends of the continuum being measured are bipolar. And 3, there is a neutral point. Okay, the issue with the first assumption is that results scale is meant to be calculated without asking multiple questions. It's difficult to measure distances between categories. Okay, excellent. Does everybody understand that? And the way a Likert scale works is it's always an odd number. The lowest is typically 5, and it goes, okay, respond to the following statement. Dr. Gardner is the best instructor I have ever had in my entire life, starting from the age 5. Number 1, strongly disagree. Number 2, disagree. Number 3, no opinion. Meh, I don't know. Number 4, agree. Number 5, strongly disagree. Okay. Likert scale is helpful to researchers because it makes putting somebody's reaction neat and tidy. You put into these categories. But in the mind of someone, what's the difference between disagree and strongly disagree? Does disagree is like, yeah, or I don't think so. Strongly disagree is like, ah! People may not have that level of reflection about their reaction, their opinion, their position on something. And, like, I got to pick something. It's like, okay. So it can skew what's going on. But then you go, oh, look at the numbers. Look what the numbers say. And then you're back to getting fooled by the numbers. Good answer, Ashley. Question number 4. Are emotions best listed as categorical or continuous variables? Why? Are sex characteristics best measured as categorical or continuous variables? Why? Okay. Drawing from the two previous questions, is gender best measured as categorical or continuous variables? Why? Oh, does Dr. G love to push the buttons? And indeed, I do. Now, it's in this answer that I'm going to get to how it is that we decide what's the best means by which to describe a phenomenon. Because it's not random. We go, what are we going to use today? Spin the wheel. No, there's a rhyme and reason behind it. But let's see what you said first. Trinity. To me, okay, and that's good, Trinity. But what I want to know is what the data says. All right, I'm not poking at you. Everybody, on notice. Emotions make the most sense as continuous variables because they don't switch on and off. They shift in intensity, and trying to force them into categories loses information with it all than it can. Okay, maybe I'm reading this wrong. Trying to force them into categories loses more information. I'm sorry, I missed that. Within it all than it can help. Sex characteristics, by contrast, usually best measured categorically because measurement tasks the most in most research about classification rather than degree, even if the biology itself is more complex than the boxes we use. Gender lands closer to emotions and sex characteristics, okay, which is why it works better as continuous variable. Genders reflects identity and lived experience, not just measurements in fixed groups. Treating it as just categorical assumes boundaries that don't exist for many people. Okay, let's take a look at what you said. Okay, so first and foremost, yes, emotions are best measured as continuous variables. Why? Because we do not switch our emotions on and off, nor do they fall into set categories like, say, our height or our eye color. Okay, I mean, you can put contacts in or whatever, but if you're, like mine, if your eyes are brown, today, they're going to be brown tomorrow. Okay, this is best expressed as emotions, as a continuous variable. Likewise, sex characteristics are also expressed as, are best expressed as categorical variables. Now, here's where things get a little tricky. And, I've read through many of your answers. Let's see if there was someone okay, continuous. Let's see, when we get to gender. Okay, continuous. Okay, all right. Here's what I want to suggest, and I'm going to give you the reasons why. Gender is in fact a categorical variable. Okay, because we're living in a time and place in which that term, the clinical term, has been redefined, and gender has forever in the biological and social sciences been synonymous with sex. So it's a categorical variable. Now, if you want to talk about people's tendency by way of expression of gender traits, okay, that's fine. Some gender, male gender, express more masculine than others. Some female gender express more feminine than others, and vice versa. Some male gender individuals express more feminine than others. That measurement, perfectly legitimate for the continuous scale, the expression of the thing. But why is it that, and I told you, I'll get to, why is it that we would assign categorical as opposed to continuous? And here is the why. I need my Sharpie marker. Okay. One of the really interesting things to me about statistics and science is, or the study thereof. I mean, science just comes from the Greek word and familiar to Western Speakers in the Latin form is scientia, which just means finding out about, the knowing, which applies to everything. One of the interesting things to me about empirical research, okay, I'm just going to say science again, but okay, is how well it actually fits with what is, you know, sometimes seen as separate from science, that is religious perspective. Because in the so-called, and really there's not a separation, but you know, I'm giving you the socially expressed opinion. All right, understand that. Because there's this socially expressed opinion that religion is over here and science is over here, and they're opposed to each other. No, they are not. Starting with religion, and we'll speak for the one that we practice here at Regent, Judeo-Christian religion. The assumption is that there is a single originator to physical phenomenon, and that single originator, God, right, is perfect in form, consistent in form, and therefore the phenomenon are consistent in form. Within science, within statistics, there is an understanding that things are so consistent in their behavior. I don't know what's happening to my pen. Okay. That at the very least, and yes, this is going to be on the test. I mean, I'm being serious here with you. At the very least, any phenomenon that is not being disturbed, influenced by an outside force, will do what it does consistently, repetitively, 95% of the time. We live in a predictable physical world. Now, starting from the religious explanation, that is because it is the creation of a predictable creator. Okay? So let's go back to the 95% of the time, because there's a term in here that's really important for you to know. And that holds that if you took a coin like this one, and hey, check this out. I was, you know, here's my tough bougie life. I was shopping in a flea market just this last year in Vienna, Austria. And I'm walking along and I see this coin. See that? And I go, oh, that, you know, I don't know what, I mean, I don't really collect coins. I said, oh, what is that? And I flip it over, and it is an American silver dollar minted in 1872. And sitting right next to it is another American silver dollar minted in 1876. And they're just sitting there on this table. So I say to the vendor, I think she was Serbian. I said, how much for these? And she's like, oh, you know, I ended up paying the equivalent of about $3 a piece for these. I haven't had them valued yet, but my guess is they're going to be worth more than $3. Anyhow, back to the point. So the assumption about how reality works is that it does the same thing 95% of the time. Meaning, if you took this wonderful find of a coin, and there's Liberty on the front, there's heads, and then there's the, you know, this is a US silver dollar, there's tails, and you flip the coin, all right, 100 times, you would expect to find, if there's no external influence on this coin, you would expect to find a split between heads and tails that would fall into 95%. It wouldn't be 50-50. It would be 95% or above. It wouldn't go below 95%. So, you know, it might, if you flip multiples of 100 times, let's say you know, it's raining and you're bored, okay? And you and your friend are like, yeah, what's gonna do today? Hey, I know, let's flip a coin 500 times. Why not? If you flip it 100 times, 5 times over, let's say you flip the coin and your friend records what you call out, heads or tails. Over the 5 sets of 100 times, if there's nothing influencing this coin, you would expect that when you average those out, that the very lowest, 95% of the time, it would be split between heads and tails. So in one of the hundreds, it might be, you know, 48 tails and 52 heads, or maybe it's 49, 51 to give you 95%. All right, and then it might flip the other way. And another one of the sets of 100, it might be 51 tails and 49 heads. And then maybe one of the sets of hundreds, it was 50-50. Okay. You would expect a 95% split. All right, meaning 5% of the time, or less, there's a variation from that. That variation between the 95 and the 5, that's called the confidence interval. Very important term. Yes, you'll see it again. Confidence interval. Okay. Now, let's say when you flip the coins, the 100 times 5 times over, that it's like 80% heads, tails split. Something, you conclude, is acting on the coin flip. Maybe, as you're calling out heads or tails, your friend who's, really wasn't keen on the game, when you say heads, he writes tails just because. You say tails, he writes heads. He's messing with the recording of the data. That could be an influence. Maybe this is not a US silver dollar. Maybe I'm the one that got taken advantage of, and it's a trick coin, and it's heavier on one side than the other, and it's designed to predominantly turn up heads as opposed to tails. That's something acting on the coin. Okay, so that tells you that there's a force at work outside of what you normally expect. It violates the confidence interval. Now, this number, 95.5% for the confidence interval, can be different depending on what you're dealing with. When they're testing new pharmaceuticals, the confidence interval is really, really narrow. Okay, it's high. It's like 98, 99%. Because if the drug that you're hoping to get approval for doesn't do exactly what you say it's going to do, like 98, 99% of the time, and doesn't do something dramatically different, if it causes like a third eyeball or a nipple to grow out of something, no, you shouldn't get approval. Okay, but that is the bare minimum, 95.5%, 5% confidence interval. What does this have to do with gender and sex? Here's why. The reason that you use categorical descriptors of categorical, description of categorical data as opposed to continuous data. If the thing that you're dealing with that you want to describe, let's say gender or sex, doesn't violate the confidence interval, it doesn't mean that there are no variations. Okay, it's best described as categorical data. And so this is one of the, on many people's parts, this is unintended because they don't understand statistics. This is one of the falsehoods gets tossed around within this ideological movement. Say, well, what about intersex people? People that are born with ambiguous genitalia, which there's such a thing. People with testicles that don't descend, because that's the difference between ovaries and testes. The one remains in the body and then produces ovum. The other one descends and produces sperm. Okay. Well, what about testicles that don't descend, or people that are born with XXY chromosomes? That you can't say that gender and sex are binary. We don't know how many. There could be thousands, millions of genders. No. Yes. There are variations from the norm, and they are just that, from the norm, but they don't violate the confidence interval. It's not higher than 5% of the population is born with ambiguous genitalia or XXY chromosomes. It's actually very low. It's below the confidence interval. So things that fall within that confidence interval are best described as category because they split into predictable categories: heads or tails, male or female, brown eyes, blue eyes, black eyes, hazel eyes. Okay. It's the ways that is it the only way to describe the world? You can have a debate about that. By way of trying to take stock of how and why things happen, and then coming up with descriptors to represent that. Is this, A pretty good way to do it. Yeah. Okay. Okay. So that's the problem. The problem is that now somewhere way back up the chain, and I happen to know where some of these places are because I, study this. There were researchers that intentionally muddled the definition between sex and gender, that intentionally muddled the established norms for applying categorical as opposed to continuous descriptors of data. Turn that loose in the public, and the public doesn't know. And so this is why you get these raging debates about multiple genders, and it's a continuum. No, it's best described as a category. In the case of gender, it's a binary category. It's male or female, which that's two. That's not thousands. And this is, look, see, there are two separate phenomenon going on here. To say that it's binary, that describes a physical state. It doesn't mean that there's no violation to the binary rule. It just means that violation doesn't violate the confidence interval of 5%. And it doesn't speak to how people feel. So if you're trying to measure how they feel, then use a continuous descriptor, use continuous data. And if you're asking about how they feel by way of masculine or feminine, that's a perfectly legitimate question. But that's very different from saying, well, because I feel this, I am this, huh? And therefore I have to use your bathroom and I have to participate in your sports category and so on and so forth. That's not sufficient justification, because now what you're saying is a phenomenon that's best described as continuous is really categorical. And since it's categorical, I get to participate in your sports category. I get to use your bathroom space, your space that's categorically designated for distinct categories. That's a misrepresentation of how data is expressed and how phenomenon work. And looking at it from the statistical point of view, that's the fundamental problem. Okay, do you understand? All right. Yumpin' Yiminy, 52 minutes. Maybe I hope you turn this off and you went and got a snack or something. Okay, everybody. Thank you so much for your hard work. I look forward to reading and reviewing your part 1. As soon as the deadline passes, the 13th, I will post part 2 so you can get to it. Now, some of you, have asked to interview me, and that's good stuff. I've given you direct and sharp feedback, not to knock you over the head. Okay, you know who you are, who I'm talking about, but to let you know that in training for you to be dealing with clients, there are things that clients are going to expect, and it's the marketplace, man. You've got to, in terms of selling and hitting it, we've got to rise above the level of the Walmart greeter. And I'm not taking anything away from anybody that does that. Okay, but just by standing going, oh, hey. Okay, you got to be a little sharper when you're making a presentation. So if I give you pointed and direct feedback, it's not because I don't love what you're doing. I'm trying to help you. Okay, I'm trying to help you. All right, everybody, I'll watch for those. And then, this week, I will be grading your discussion sections, weeks 1 through 4. So if you haven't finished it and it's not in, then it's the door is closed. Okay. All right, everybody. Thank you so very, very much for your hard work. I think about you. I pray about you. Have a great week. Good luck with finalizing phase 1. And I will see you on Canvas. Take care. Bye-bye.